Okay, so today we're going to go over solving equations using completing the square and the quadratic formula. Now I know we've done completing the square before, so today the difference is that we are actually going to be solving for x instead of just trying to write it in vertex form. So for example 1, we have x squared plus 12x plus 43 equals 0. Now the difference is, since it doesn't equal f of x, we can actually move this 43 over to the other side. So I'm going to subtract 43 from both sides. So I get x squared plus 12x, and I leave my blank, equals negative 43, and I put a blank on this side. So I'm still going to cut 12 in half, so I get a positive 6. Now, to find out what goes inside the blank, I take those two 6's and I multiply them together. So 6 times 6 gives me a positive 36. And unlike before where we were adding the same number on the same side of the equal sign, this time I'm adding it to the other side of the equal sign. So I can keep the sign the same, because whatever you do to one side of an equation, you have to do to the other. So I get plus 36 over in the other side. So now when I go and factor on the left side, I get x plus 6 squared. And then on the right side, I take negative 43 plus 36, and that gives me negative 7. Now to solve, that means I'm trying to get the x by itself. So to undo a square, I just have to take the square root of both sides. So then on the left side, I'm left with x plus 6. And on the right side, the negative that's underneath the square root, remember, comes out as an I for the imaginary number. And then the square root of 7 doesn't simplify, so I just leave that as the square root of 7. And then when we were doing our problems yesterday, we should have found that we had two answers. Whenever we take the square root of a problem, we get a positive answer and a negative answer. So I have to get a plus or minus the square root of 7i. And then to finish getting the x by itself, I just have to subtract 6. Now 6 is not a like term with all of that, so I can just write it as negative 6 plus or minus the square root of 7i. Let's do another problem. This time, I have 4x squared plus 76 equals 16x. Alright, so I need the x squared and the x term to be on the same side. So I'm going to subtract the 16x from both sides. And I'm also going to subtract the 76 at this point in time, so I can have room for that blank. So I have 4x squared minus 16x equals a negative 76. Now remember, when we complete the square, we're not allowed to have a number in front of that x squared term. So to get rid of this 4 here, I'm going to divide both sides by 4. So when I divide the left side by 4, I'm left with the x squared minus, now 16 divided by 4 is a 4x. And then I have my blank. And then negative 76 divided by 4 gives me a negative 19. And I have a blank on this side as well. So now I can cut my 4 in half. Because it was a negative 4, I'm going to get a negative 2. And then to find out what goes inside the blank, I have to multiply negative 2 times negative 2. So that's where I get a positive 4. And whenever I add 4 to one side, I have to add 4 to the other. And now I can factor the left side and get x minus 2 squared equals, and then I have negative 19 plus 4 gives me a negative 15. And then to undo a square, I have to take a square root. So the square root and the square cancel each other out. So I'm just left with x minus 2. And then because there's a negative underneath the square root, I have an I. And 15, if I try and do my factor tree of 15, I only get a 5 and a 3. There's no pairs, so it stays the square root of 15. And because we took the square root of the number, we get a plus or minus. So then to finish solving for x, I just have to add 2 to both sides, and I get x equals 2 plus or minus the square root of 15i. And that's it. Next, we're going to use the quadratic formula to solve. So for the quadratic formula, I'm sure you all remember this. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And in order to use this, your quadratic equation has to be in the form of ax squared plus bx plus c equals 0. So essentially, we need it to equal 0. Now we're going to use this a lot, so you need to have this memorized. I don't care how you memorize it. If you have a little rhyme or a song, I have a song to memorize it. I can sing it for you if you want. It goes to the tune of Are You Sleeping? And it goes like this. Negative b plus or minus the square root of the quantity b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. It's a pretty simple little song, but it helps memorize what the formula is, so we can use it. All right, so for our next example, we're going to use the quadratic formula. So we have negative 3x squared plus 8x minus 7 equals 0. Now, written in this form, notice that it's written so it's equal to 0. So I know my a is going to be negative 3, b is going to be 8, and c is going to be negative 7. So now I just have to plug it in to the formula. So I get x equals, now I have negative b, so that would mean the opposite of 8 is negative 8, plus or minus the square root of b squared, so that would be 8 squared, minus 4 times a, which is negative 3, times c, which is negative 7, all over 2 times a, which is negative 3. So now we just have to simplify. So underneath the square root, when I take 8 squared, I get 64. And negative 4 times negative 3 times negative 7 gives me a negative 84. All over 2 times negative 3 is negative 6. So now when I take 64 minus 84, I get negative 20. Then I know the negative part, since it's underneath the square root, comes out as an I. And then if I would take my factor trees of 20, I get 5 and 4, and then 4 and 4. So I have a pair of 2's. So remember, the 2 goes on the outside, and the 5 stays left underneath, all over negative 6. So then here, I'm noticing I have negative 8, negative 2, and negative 6. So they're all even, so I can divide them all by 2. So actually, and then the negative 8 and the negative 6 are both negatives, and so those would cancel. So I would get 4 plus or minus the square root of 5i all over 3. And so if I want to write this in standard form, it would just be 4/3 plus or minus the square root of 5 over 3i. All right, so let's use the quadratic formula to solve Again, this time, the problem we're solving is x squared minus 9 equals 4x. So we want to get the x squared and the x terms on the same side, because we have to have it equal to 0 in order to use the quadratic formula. So I'm going to subtract 4x from both sides. So I get x squared minus 4x minus 9 equals 0. Alright, so now that it's equal to 0, we can use our quadratic formula. So this time a is 1, b is negative 4, and c is negative 9. So when I plug it in, I get negative b, so the opposite of negative 4, or negative negative 4, would be a positive 4, plus or minus the square root of b squared, so I get negative 4 squared, minus 4 times a, which is 1, times c, which is negative 9, all over 2 times a, which is 1. So now to simplify, underneath the square root, I'll take negative 4 squared and get 16, and then negative 4 times 1 times negative 9 is a positive 36, all over 2 times 1 is 2. So 16 plus 36 gives me 52. I'm going to do my factor trees of 52. So that would be 13 and 4, and then 2 and 2. So I have a pair of 2s. So I get 4 plus or minus 2 square root of 13 all over 2. Notice I don't have an imaginary number here. I don't have an I, because there was no negative underneath the square root. So now here, the 4 and the 2 and the 2 are all even, so I can divide all those by 2. So I would get 2 plus or minus the square root of 13. I could technically write it over 1, but I don't need to. So I can just leave my answer like that. All right. So we'll have homework, and we'll go over questions on Monday.